Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about dreams of dark matter, and if I have time, buzzing the solar system, and basically, we're never going to get a James Webb Space Telescope, and of course, taking listener questions about all things, because this show is about the entire universe. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about scientism, whatever that means. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent to the stars. We've got an exciting show for you today on Space Radio. If it's above the Earth's atmosphere, it's in this show's universe, and it lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. Call 888-581-0708. You can also follow along on our live streams on YouTube and Twitch. Check out spaceradioshow.com for the links. I'll take questions that you send there too. And hello to the Space Cadets on today's live stream from Cerritos, California, Norg, Netherlands, Zagreb, Croatia, north of England, which might be Scotland, perhaps Athens, Greece, Hutto, Texas, and more. You can join their wonderful, wonderful online party every Thursday at 4 p.m. Eastern. That's spaceradioshow.com for the links. Get those questions in any way you can. I've only prepped 10 minutes of show material, so let's get talking. Before I start taking calls, I wanted to share some interesting bits of news I caught recently. And this story just broke a couple days ago, and I was reluctant to talk about it, so I'm going to take a different spin on it than you might be used to. The news was that astronomers found a galaxy with no dark matter, and that somehow upsets everything we know about cosmology, etc., etc., etc. So first, some clarification. The astronomers found a very, very small dwarf galaxy, more like a globular cluster, a very, very small guy. And we know from decades of evidence that every galaxy of stars and dust and gas is embedded inside of a much larger halo, what we call, of dark matter, of non-visible matter. And these researchers went to weigh the amount of dark matter. Even though we can't see it, the dark matter has an influence in gravity, so we can still detect it through the motions of stars and other objects in the galaxy. And they went to weigh it, and there wasn't as much dark matter as normal when we see a typical galaxy. There wasn't zero. There was just a relative less amount of dark matter than you would expect. Maybe zero, maybe not. This is a very rough measurement. It is astronomy. After all, kind of hard to take measurements of stuff millions of light years away. But they did it, and they have there's not a lot of dark matter in this object. So what does it mean? Well, it could mean nothing at all, because our knowledge of the relationship between dark matter and visible matter is based on statistics. It's based on collecting thousands, even millions of data points from all across the universe where we build up this relation. So it's not surprising that every once in a while you're going to find an oddball with someone with a little bit too much dark matter, a little bit too little dark matter, etc., etc. And I see a lot of you every time the topic of dark matter comes up in the news. I read online, like Reddit and /die, the chats and all this kind of stuff, and I see people comment. And something that really irks me personally is when someone comments like, oh, this whole dark matter thing, it's just a kludge, we're just making it up, it's just a placeholder for something we don't understand. I will be the first to admit that we don't fully understand dark matter. Straight up. But I'm going to push back. It is not a kludge. It is not a fudge factor that just represents something we don't understand. Because dark matter, whatever it is, even though we don't fully understand its properties, whatever it is, it has effects in our universe. It shapes galaxies. It shapes galaxy clusters. It shapes the large-scale distribution of matter in our entire universe. And we can see these effects. These are detectable, observable, measurable things. that we have seen, that we have measured, that we have detected. We know something like dark matter is out there. We don't fully understand its properties. We don't fully understand what it's made of. It's our best guess is it's some strange creature, some exotic particle previously unknown to science, but that's okay. For the past 100 years, we've been detecting new kinds of particles like crazy that we've never known about before, so that's nothing special. But it's there. We see it. We see the gravitational effects. We see the way it bends light around it. Matter in the universe is under no obligation to be all hot and glowy. There is dark matter in our universe. It is not a kludge, even though we don't fully understand it. It's a hot topic. I wish we understood it better, but that's science. That's science. There are mysteries in their universe, but this is a mystery that we're chasing after. That is my commentary on that piece of news, and it's time to have a conversation. And we've got a caller. Hey, Randy, thanks for calling Space Radio. This is not your first time calling the show, is that right?
That's right. You've got a good memory.
Greg, my producer, told me that you've already called before. I don't remember what happened to me 15 minutes ago. In fact, I may have started this show. I don't even know. I live in the moment. So, Randy, what's your question for the show today?
I was just curious to know, I was kind of thinking the other day when I heard that SpaceX launched a heavy lift rocket. That would, of course, make things cheaper to get into space. But a while back, there was talk of a space elevator made out of carbon nanotubes. And there was kind of high hopes that would revolution. It would if they could use that to hoist stuff up into space and make it so cheap you could build, basically, starships outside the the Earth's atmosphere. And I haven't heard anything on it. And I didn't know whether that was just nobody's working on it. Is it really even somebody even thinking that they can even pull that off? Or is it just kind of science fiction?
That is an excellent question. So you hear every once in a while space elevator, and you're curious, what's up with that? Pun very much intended. So the basic idea behind a space elevator is that getting to space is ridiculously expensive. You need fuel, you need to light it on fire, it needs to blow up in a very controlled fashion. Most of the time you ditch the rocket and you end up spending millions upon millions of dollars just to put a tiny little thing the size of a bus in orbit like a satellite. So is there an easier way? Is there a cheaper way to give us access to space? And people have been brainstorming ideas for as long as we've thought of going into space. And one of these ideas is a space elevator. Now, I don't want you to think of a elevator that's like inside of a skyscraper. It's supported by concrete and there's a tube in the middle with cables. Not quite like that. So the magic of a space elevator is that you put the counterweight, the top of the elevator, you put it in orbit. So it's way up there. It's like 100 miles up, however high you want it to be. And it's orbiting the Earth at tens of thousands of miles per hour. And then from there, that's already in orbit. It's already suspended. So the top is already up there. And then from there, you can imagine dropping a line back down to the ground. The ground, and this line doesn't even have to touch the ground. You're not going to attach it to the Earth. It's just going to hang out in the atmosphere, trailing underneath this big giant installation that you've put in orbit around the Earth. So once you've got the big thing in orbit and you've got the rope coming down, that's a way to get to space. You can imagine just grabbing onto that rope and pulling yourself up, hand over hand, shimmying your way up, and eventually you'll be in orbit. It will be kind of slow to get up into orbit because it's not like a rocket that's going to blast you that quickly, but it's very, very inexpensive because if you could do it just by climbing, the same energy you would put into climbing a ladder, you could reach space. So the elevator is a concept where there'd be a car riding along this cable that takes you from the ground to this big, massive counterweight in orbit around the Earth. And ta-da! Access to space is super cheap. Slight problem tiny, tiny, tiny technical issue is this material, this rope that is whipping through the Earth's atmosphere at tens of thousands of miles per hour, is supported in orbit by this massive multi-ton installation, like something like the International Space Station times 10 or whatever. And that material, that is a lot of tensile strength. Like that rope is being pulled really, 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 really hard because there's a lot of difference between being on the ground and being in orbit. And none of our materials, either existing ones or reasonable projections of existing materials, can do the job, have enough strength to do it. Plus, as this cable is whipping around the Earth, there's going to be a lot of gravitational perturbations, let's say. The cable's not going to be straight. It's going to start whipping around. It's going to start seesawing around. So even if you had this incredibly strong material, it's not like a smooth sailing elevator ride to the top of the Empire State Building, get those panoramic views. No, it's going to be violently jerking you back and forth in the atmosphere, giving you severe whiplash. So one, we need this fantastic material with incredibly strong properties that's cheap to produce, which we don't have. And two, there are all these extra gravitational interactions that you need to account for in order to build it. So people have proposed, you mentioned carbon nanotubes. Carbon nanotubes are a way of manufacturing carbon in a particular molecular arrangement that have some very, very specific properties, some designer custom properties. And yeah, you might be able to make a little thin wafer in a petri dish, or, the molecular equivalent of a petri dish. You're not building a tens of miles long cable into orbit. We need to take a break, but I want to keep you on the line, Randy, because I want to keep talking about this. So stay on the line. And remember, this is Space Radio. I'm Paul Sutter. This show is brought to you by you. Visit patreon.com/PMSutter to learn how you can support the show. That's right. You are making this show happen. And I greatly appreciate it. See you after the break. All right, Randy, just stay there.
Okay.
Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got Randy on the line, but remember, you can join the conversation by calling 888-581-0708 or by following the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. Now, Randy, I talked about the issues with Space Elevator. Did that satisfy you? Do you have any follow-up questions?
Yeah, I think what I remembered of the reports that were, this is probably well over a year ago, maybe a couple of years. They showed sort of the concept in drawings, and then they went to a lab where somebody was making a carbon nanotube material that was maybe about the size of a paper towel, and that's as far as they had gotten. And it's kind of like, as you said, they've got to make something that's 100 miles long, and it just doesn't sound like it's even possible. They've got a long way to go, and I didn't know if people had just given up on the idea because we really won't have something strong enough that would be the cable, if you will.
Right. And the Space Cadets in the live stream mentioned there's a video on YouTube talking about advanced metamaterials and this concept of advanced engineering concepts of trying to create materials with properties that we want, manipulating things at the molecular level, at the micro and nanostructure level, so that we can arrange the atoms just so that the macroscopic object has all the properties we want, like really ductile or really have a lot of tensile strength, or it doesn't shatter or whatever. And that's great. And that is a 100% legit active area of research, not necessarily applied to space elevators. Material scientists are researching and discovering materials every single day. And it's a fascinating scientific discipline and engineering challenge. If there are materials that have that right sweet spot where they can be manufactured easily, they can be manufactured cheaply, they can be manufactured at large scales, then boom, you know that industry is going to adopt it. That all of a sudden your car will be made out of 80% super weird materials that your parents didn't know about. But when it comes to space elevators, I really, really think I try not to be a sourpuss on like everything, but I'm not 100% excited by space elevators because the materials challenge there is almost so overwhelming that it's hard to get around. That you can project out like, okay, even if we had 100 years, 200 years of materials design, like there may not be a particular arrangement of atoms and molecules that give you the properties that you want and need for a space elevator. But who knows? You know, the future is always full of surprises, which is why it's in the future. Thank you so much for calling, Randy. It was great talking to you. Excellent question, because we seem to be on the cusp as a society, as a culture, where there's this feeling, and maybe I'm the only one that feels it, that there is a revolution coming in access to space. You know, when you look at what the private sector is doing, SpaceX, Blue Origins, all the others, where they're taking very simple ideas like, oh, let's put a rocket, but then bring the rocket back so we don't have to trash it in the ocean every time. And you look at the projections of how cheap that can make access to space, that's something special. That appears something special, and that I can get excited by because it's a thing that's happening like right now. I can go and watch YouTube videos of it happening, and that I can get excited about. I don't have to just cross my fingers and hope for a magical material that may or may not ever materialize. So, also on the live stream, we got a very interesting question from the Space Cadets from Constellation Pegasus, asked right at the beginning of the show, right when I started going live, of what happened to space when inflation was occurring with its exponential growth, what was in between the jumps when inflation was occurring and stopping when regular expansion started. Great question, Constellation Pegasus. Now, he or she is asking about inflation. Inflation is one of the cornerstones of our modern understanding of the history of the universe. And we strongly suspect, and there's a fair amount of evidence to back this up, that when the universe was incredibly young, like less than a second old, it underwent an incredibly rapid period of expansion where it inflated, hence the name, from like the size of an atomic nucleus to the size of an apple or something like that. Now, that doesn't sound very impressive, but for the universe, when it was less than a second old, that was pretty impressive. It was much more rapid expansion than it had ever seen before, and it will ever see since in the billions of years after. And now there's a whole set of questions of what the heck powered inflation, where did it originate, what triggered it, how did it slow down and stop? That's a whole big old kettle of fishy worms, like barrels of monkeys and fish and worms, lots of wiggly squirming things that we're still trying to understand. It's an active area of research. But asking what was happening to the universe during this event is something that we can tackle. And what was happening to the universe during the inflation event is exactly what's happening to the universe now. Right now, as I speak, the expansion of the universe is accelerating. Not only are galaxies getting further away from each other on average, they're getting further away from each other faster and faster. And this has been going on for about 5 billion years. We call this dark energy. That's a whole other problem in modern cosmology that we don't understand. But again, it's an observed effect. This is something we see with our instruments, with our data. We see it in our universe, this dark energy thing. This means that there is more and more space being quote unquote generated, that the distances between galaxies on average are getting larger and that rate is increasing. So if you go out and you measure the distance between galaxies, you get out your meter stick, your yardstick, whatever metrics, whatever system of units you prefer, you measure the distance between galaxies, then you write down a number, then you go check the next day, and it's going to be a longer distance. That's what it means. Now, during this inflation event in the very early universe, this was happening like nutsoid. This was going crazy. Now, there weren't galaxies, there weren't stars, there weren't people around to take pictures and figure this out, but it rapidly expanded the distance between objects in the incredibly early universe. Then the universe slowed down its expansion. It even began, it didn't quite contract, but it was slowing down. It was being nice and sedate for a few billion years. Then dark energy took over 5 billion years ago, and it's like inflation is happening again, but it's like the sequel to inflation, and like any sequel, it's not as good as the first. So it's not as rapid, it's not as heated, the expansion rate isn't as ferocious as it was in the inflationary epoch. We don't think, and that's for the reason we don't think our current epoch of dark energy accelerated expansion is connected to the inflationary event. Maybe. We're not 100% sure on that. That's why I love doing shows like this, because we get to talk about stuff that is at the absolute forefront of research. Dark matter, dark energy, inflation, and space elevators. But this is stuff we don't fully understand. And thank you so much for giving me the opportunity to share the latest research with you. Those were amazing questions. We're almost out of time. Man, time flies on the show, doesn't it, Greg? It just goes too fast. But before we go, it's time for the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I've tossed around this word because I haven't gotten to the topic because other things have come up. This word scientism. This word scientism, and I wanted to address it. And I don't have any notes in front of me. I'm ad-libbing. You're going to hear some pretty raw thoughts, unfiltered, and not clean, not fully fleshed out. So I want to spark a conversation. So whatever I say today, whatever I say in any show, feel free to go to spaceradioshow.com, send me an email, call up the next week, go on the live stream, join the Space Cadets on the live stream, and feel free to react to what I say in previous shows, even though I won't remember, because I don't even remember what I did 15 minutes ago, but you can refresh my memory, you can keep that conversation going. Scientism is when you're a fan of science, which, yay, but you take it to the extreme. So it's like the difference, I'm going to say this, it's like the difference between patriotism and jingoism. It's one thing to be proud of your country and where you live. It's another thing to be so proud of your country that it turns into perhaps hate and denigration of other countries. And that's where it can become poisonous. And that's why I'm always supportive of fans of science, because you're paying my bills, you're watching my shows, and I greatly, deeply appreciate that. But we have to be careful. If we're fans of science and the scientific method and critical thinking and all the good stuff that comes with the science package, we don't want to turn that into denigrating or hating other ways of thinking, other ways of approaching the world, other ways of having thought and having ideas. And I see this sometimes in science communicators where there's a tendency to go from yay science to boo everything else. And I think that's dangerous. I think that leads us down a path that we are not going to enjoy. Where, it may speak to the base. This kind of cheerleading might rally the troops, so to speak. But if you turn off everybody else who isn't already in the yay science camp, then how are we ever going to have a meaningful conversation? How are we ever going to have dialogue to work out our issues? Like if we believe that science is in trouble, because of lack of funding, because of lack of faith in the public of science and the scientific method. We need to start having conversations with people who don't necessarily subscribe to our point of view. And we absolutely have to do it. We don't really get a choice if we want to survive, if we want to live, because it's not a competition. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. The show is also brought to you by you. I can't emphasize this enough. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Nishalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. And you can also catch the YouTube and Twitch live streams. You can also follow me directly on social media. It's at Paul Matt Sutter on all the platforms. Go to spaceradioshow.com for all those juicy links. And thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Thank you, Space Cadets, on the live stream. Wonderful questions. Sorry I couldn't get to all your questions because this show's only a half hour long. We are working, though, to make the show an hour long, bring in guests, be able to have more conversations and discussion. It's coming. It's coming down the pike. But first, you have a very important job. I need a title for this show. So whatever you guys think should be the title, feel free to pop it into the chat. And I will take it for consideration. I'm not going to promise you that yours is going to be the one, but I need some ideas because I'm really, really bad at titles. I would much rather get a good idea from someone in the chat. Scott Bragdon on Twitch. Yes, twice as much fun. Perhaps if the show were to jump from a half hour to an hour, I suspect it might be 2.4 times as fun. I think we're going to have some multiplier effects because I'll be able to bring in guests and be able to interact with them and have you, the callers and the live streamers of the Space Cadets, interact with the guests too and ask them questions. That's a multiplier. So it's more than 2. It's like 2.4. Longest elevator music ever. I like that for the name of the episode. I really like that. SAHM. Dark matter elevators. We got some good ones. I like how you're honing in on the elevator on Randy's call-in question. Dark matter elevators. I like something about longest elevator music ever. Because this is probably detrimental to the show. I actually like it when the titles almost make no sense and don't really talk about what's in the actual show. I know it'd be useful to have, a title that connects directly to the topics, but I just like joke titles. I don't know. It's amusing to me and it's my show. So, it's my fault if it doesn't do as well as it could have. Longest elevator music ever. I think that's going to be the winner. All right, we got to pack up today. Thank you so much, everyone, for watching. And I know I've been off and on the past month or so. I've had to do some unexpected traveling, so I wasn't able to go live. But I will be live next week, unless Greg is sick or gets in an accident.
That's true. We talked about that.
We talked about that, and we have no backup plan for Greg, unless one of you wants a job. So see you guys next week.